At his current valuation, Elon Musk manages a portfolio of 5 distinct industries, each dominating a different sector of the global economy. The electric infrastructure of Tesla, the orbital network of Starlink, the neural interfaces of Neuralink, the machinery of the Boring Company, and the generative models of xAI. These companies solve the specific engineering bottlenecks required for a self-sustaining Martian colony. For decades, Musk has been assembling these technologies into a single, interoperable stack. The consumer products currently used on Earth serve as a global proving ground, allowing humanity to finance the development of its own off-world survival hardware. The observable universe contains roughly 2 trillion galaxies. Statistically, intelligent life should be common, yet we see zero evidence of extraterrestrial civilizations. This contradiction is the Great Filter, a lethal evolutionary bottleneck destroying advanced civilizations before they expand. Nuclear weapons, resource depletion, and biological threats align with these extinction patterns. Establishing a second biosphere creates a branching path, avoiding total species collapse. Achieving multi-planetary status via Mars is the only mathematically viable way to bypass this filter and ensure human survival. Mars is an environment of extremes. The atmosphere is 95% carbon dioxide, temperatures drop to -125 degrees Celsius, and the lack of a magnetic field exposes the surface to constant cosmic radiation. Crossing the 140 million-mile gap to Mars requires a staging area to test life support and orbital logistics. The Moon, located just 3 days away, serves as this critical laboratory. The Apollo missions focused on exploration and short-term survival. Today, the focus is permanent infrastructure, fuel depots, and massive launch pads designed specifically to reduce the immense energy cost of leaving Earth's gravity. The first human crews face a lethal labor bottleneck. They cannot survive long enough in the Martian vacuum to manually build the massive, pressurized habitats required for their own protection. The mission's success depends on an automated base being operational long before the first human arrives. AI and humanoid robotics provide an unbreathing labor force. These systems are capable of 24-hour construction in high radiation zones that would kill a human worker in days. Martian machinery requires a power source that does not depend on local chemistry. Internal combustion engines are impossible because they require atmospheric oxygen to burn fuel. Tesla's lithium-ion battery architecture and solar capture grids provide a closed-loop system. This allows for mobile and stationary power on a planet with zero fossil fuels. Long-term surface habitats are vulnerable to solar flares. To protect life, colonial infrastructure must move underground. The Boring Company's drilling technology allows for the rapid excavation of pressurized, radiation-shielded subterranean cities within the Martian crust. Starlink's orbital mesh network provides the template for a global communication grid on a world without pre-existing undersea cables or physical fiber networks. When viewed together, these industries form a survival stack specifically engineered for the physical constraints of the Martian environment. On Mars, reaction time is a survival variable. Managing complex life support systems and thousands of automated sensors in real time exceeds human biological bandwidth. Neuralink provides the high-speed interface needed to integrate human consciousness with the digital systems required to stay alive. The endgame is terraforming, the process of warming the planet and thickening the atmosphere to restart the water cycle. This phase transitions Mars from a mechanical outpost into a self-healing second biosphere for humanity. We are witnessing the secret prototyping of interplanetary infrastructure under the guise of an Earth-based consumer market. Managing the logistics of a multi-planetary move requires the immense computational power of the back-end servers currently training our AI. The Mars mission operates as a mathematical insurance policy for human consciousness. The blueprint is complete. The question is whether humanity can survive its own growth long enough to finally leave its birthplace.